I am going to add a few more podcasts to this net zero story because it remains hot and different aspects, different perspectives, different issues with the concept keep being researched and reported. So this is from a Nature Climate Change paper that's cited here that talks about the meaning of net zero and the attributes of a net zero framework as such. So here we are looking at net zero balance of carbon emissions and removals. A to C, current anthropogenic carbon flows to and from the atmosphere are not in equilibrium. This matters. Emissions from fossil fuels, industrial processes, and land use change by far exceed the removal of carbon into land use related sinks. As you remember from the carbon cycle discussion, right now land use is taking up a tiny bit of carbon, acting as a sink. Net zero requires anthropogenic flows to and from the atmosphere to balance on aggregate. It seems obvious, but we have to state it. This necessitates a radical reduction in fossil fuel and land use related carbon emissions, as well as an increase in geological and biological sinks. Durable net zero further recognizes that biological storage is limited in capacity and short-lived than geological storage. Again, we have talked about planting trees as a solution and the fact that mature forests begin to slow down in carbon uptake, plus they may burn up and release all the carbon in an instant, but geological storage has to take care of such leakage problems and so on. A durable net zero state therefore requires that net anthropogenic flows to and from each sphere, not just the atmosphere, equals zero, which means that typically when net zero is being talked about, we are tracking only atmospheric CO2 and not the other reservoirs in the system. Plus, oftentimes we are not talking about other greenhouse gases either. So the idea of reaching net zero has to still track N2O, methane, and other greenhouse gases as well for meeting the global warming targets on time. So that shift has to be noted as well. Note that natural flows of carbon are not shown in this figure and involve a small net flow from the atmosphere to the biosphere when net zero is reached. So what happens when we reach net zero in terms of natural reservoirs is still critical. So anthropogenic carbon flows into the atmosphere are imbalanced right now. We are in a transient state. So lithosphere emissions from fossil fuels and industrial processes is the biggest contributor to the entire debate and impact of human activities on carbon cycle, climate change, and everything else we are discussing. When you look at land and ocean biosphere, there is a sink from land use change that is reported in several calculations, order of 1 point some petagrams or gigatons of carbon per year. Emissions from land use storage, on the other hand, are increasing, so we have to be careful in the current situation. In the net zero situation, anthropogenic carbon flows into the atmosphere are balanced, temperature stabilized temporarily, so the committed warming will continue to warm, accumulated carbon will continue to add to the warming for much longer, centuries at least. Emissions from fossil fuels and industrial processes will still continue, but we will have sinks from air capture and geological storage, which will be much smaller than what we are emitting. And as for the land-ocean biosphere, emissions from land use change will decrease if done well, but the sinks from land use change have to increase quite a bit. So sinks from biomass capture and geologic storage also have to take out carbon from the land and ocean biosphere, and I will record a separate podcast on Ocean CDR, Ocean's Role in Carbon Dioxide Removal, from a National Academy report later on in this section as well. Okay, so if we want to make this net zero durable, then obviously we have to worry about a few more things. Anthropogenic carbon flows in and out of each sphere are still balanced. Temperature is still stabilized sustainably. Emissions from fossil fuel industrial processes have to decrease relative to this, and the sinks from air capture and geologic storage will go on, and again we will have emissions from land use change decrease as well, and also the in the durable situation, the equilibrium will mean that the land use sink will also get smaller, as you can see from the relative size of the arrow here. And sinks from biomass capture and geologic storage have to make sure that there is actually a durable net zero. So what are the attributes of such a durable net zero framework as such? So this paper says attributes of net zero as a frame of reference must consider the urgency of zero and the integrity of net, which is what we mean by these different spheres, and consistency with sustainable development objectives, which are enshrined in the Sustainable Development Goals, for example. So under urgency of zero, we will need lots of front-loaded emission reductions. Each country is declaring some net zero goal out multiple decades. India at 2070, China at 2060, US at 2050, I think Sweden is at 2035, and so on. But this is too far away in terms of how quickly we get to net zero, because or to zero, because the accumulation of carbon in the meantime can do serious damage and easily exceed the global warming targets we have set at 2 degrees, let alone 1.5 degrees C, with 67% probability by 2100. So there has to be a comprehensive emissions reduction as well. Under integrity of net, we have to cautiously use carbon dioxide removal, because that removal can be not guaranteed to be net unless there are lots of monitoring, verification and reporting, and effective regulation of carbon offsets, where people can continue to emit but pay someone else or do something else to offset the emission. So it's not really net zero. So you emit here and put a few plants over there. So verification, monitoring and reporting of offsets itself can be an issue as well, in addition to how it affects the net. So in terms of consistency with sustainable development objectives, equitable transition to net zero is necessary, so that any geoengineering of direct air capture and carbon dioxide removal into the ocean, land, geologic storage, etc. have to ensure that it's equitable in terms of the impacts, socioeconomic and climate impacts, extreme events, and so on and so forth, and socio-ecological sustainability. So biodiversity and other things have to be protected as well, and there have to be new economic opportunities for countries which are paying a heavier price despite not being major contributors to the global warming and emissions as a whole, but also new economic opportunities for everybody, so that the incentives for driving towards net zero remains very high, and the entire debate about climate change, whether it's man-made and so on, has to basically disappear at some point. So carbon offsets from the UNEP document shows that offsets are only part of the answer. So typically companies, governments needing to meet their emission targets are doing investments in emissions reduction projects in developing countries, which include offsets by tree planting, renewable energy projects and so on. But actual accounting of how much is emitted and how much is offset, because this is instantaneous emission often, and these are time-bound reductions. So growing trees and renewables offset, but not at the same time scale. Plus, certificates are obtained for payments of carbon offsets, require that these are monitored very closely and not being used in a way to, just provide certifications to get funding, for example. Okay, and all this is still happening in the framework of carbon trap or carbon fractal. Fractal, just briefly, I have separate podcast explaining it. It's basically a kind of a self-similarity which came out of the dynamic systems chaos literature. So as you keep zooming in, you can see the example here. The self-similarity is obvious, so that the features look similar and similar no matter how small a scale you go to. In that sense, the system right now we are in, no matter what you are doing, whether you're buying food, buying water, driving, flying, buying books, whatever you are doing, you are emitting carbon. There is no way to make sure in a life cycle analysis sense that you are actually being carbon neutral or how much reduction you are making in your carbon footprint. So the paper argues that we need to change the metaphors from conventional emissions reduction kind of arguments which lead to Paris agreements and then the point that emissions are not really reducing so far, to decarbonization. That's the proposed framework. So under the conventional emissions reductions approach, we are thinking about global commons like the ocean, the atmosphere, biodiversity, and so on. And the goal then becomes production of public goods and distribution of emissions reductions to all the parties, and then everybody is heading towards net zero, for example, without changing, without saying much about how the system itself is going to change to reach those emissions reductions and net zeros, which is the idea of the other paper we just looked at in terms of the attributes of a net zero framework and considering actual complete net zero among all the spheres, land, ocean, atmosphere, not just the atmosphere. The political response has been to have a global collective action to produce multilateral treaties, which despite 25 years of negotiations haven't been incredibly efficient and lagging in terms of the speed with which we need to move towards meeting the global warming targets. In the proposed decarbonization framework, it leads to the metaphor of a global fractal instead of global commons. So look at systems which are self-similar in terms of carbon emissions. So that requires a goal of disrupting carbon lock-ins and catalyzing transformation at multiple levels so that you remove this idea of doing things at one scale and not accounting for counter productive measures at other scales which are self-similar. And the political response would be experimental, multi-level, multi-scale action to overcome the fractal carbon trap. Of course, it still requires a political response, collective action, but the entire framework would be different and we would go in a very different direction than the ones we have, like the nationally determined contributions, which are more democratic compared to the earlier Kyoto Protocol type top-down impositions. But now the part about monitoring, verification, reporting, and the fact that we are moving too slowly, so the NDCs or the nationally determined contributions have to be revised, and not everybody has done it, and not everybody may be able to do it. And even if they submit a revised NDC, they still need an action plan to accelerate the NDC contributions and so on. So this is the idea of a worrying about the meaning of net zero and the attributes of the net zero framework. Okay, so I'll add more points with the from the McKinsey report, the International Renewable Energy Research and so on. I'll keep adding as I go along, as new information that is relevant to the net zero goal become available. Okay.